what we've been looking at so far are kind of like, trinomials, like x squared plus 5x plus 6, and they're easy to factorize. This is not a trinomial, doesn't fit your normal patterns, but we've been looking at algebra quite a lot recently, so hopefully the approach for this is in your head. You've got 4 terms. In other words, you've got 2 pairs of terms. So instead of trying to come up with like a quadratic formula factorization, you should just pair the terms up, right? Sometimes this needs to be rearranged a little bit, but the example I've given you doesn't need to be. What common factor shall I take out? Cos? Right? And that often, by doing that properly, will show you what you should take out for the next pair, which in this case is just -1. So -1, 2 sine theta plus 1. Okay? So from here, I've got these 2 in common, so I'll take them out. And then I've got a cos theta minus 1 as the other piece. Okay? So then you're going to have sine theta equals -1/2, cos theta equals 1, and you can go ahead and you can solve from there. But you guys know how to do that part, yeah? So you will get better at doing that part if you need a bit of practice still. But like after this line, we've done these questions to death, so I'm not going to spend any more time on them. Okay? Okay, now guys, that's the end of the double. But being that I'm not going to be here on Friday, does anyone need to be somewhere at recess so that I can't go through the last 2 questions? If you need to go, then you can go. But I'll really like to show you 5 and 6, otherwise you will have some significant trouble with the questions in 4G at the end. So is that okay? Can I keep going? Alright, 5. Let's have a look. I'm going to write this out, and immediately you will see a problem.
Yucky numbers.
Okay, number 1, the numbers aren't very friendly, but more significantly, you got a sine squared, you got a cos squared. You could swap either of those out for 1 minus cos squared or 1 minus sine squared using the Pythagorean identity, but you're kind of stuck with this guy, right? You're like, where's he going to go? Okay, so what this should tell you is that this is going to be neither a quadratic in sine nor a quadratic in cosine. It's going to be a quadratic in tan. Now, how do we make it look like that? What you do is you take all of your terms, every single one, and you divide by an appropriate power of cos. Let me say that again. You take every single term, there's 3 of them, and you divide them all through by cos or cos squared or cos cubed, depending on the powers that you have here. So in this case, I'm going to divide by cos squared. Every single term. Okay? So what I'm going to get on the next line is going to be sine squared and cos squared is? Tan squared, right? Here, this cos will cancel with one of the cosines there. So you'll end up with -2 tan theta, right? And then on the end, the cos squareds both cancel with each other, and you get that, okay? That's a quadratic in tan. You can factorize that in terms of tan this, tan plus this, tan plus that, minus, right? And then you can solve that just like you've been solving the previous ones. Okay? Does that make sense? Can I move on?
Yes. Yeah.
All right, now, this one I intentionally have tried to throw in a bit of a spanner in the works, okay? Have a look at it. Let me write it up over here. How many terms are there on the left-hand side? How many terms are there? There are 4, right? So you'd think, okay, my approach here, 2 sine theta, what have I got? Tan? What have I got next? Sine tan. And what's that, -2? Okay, you'd think I should pair up here, and that's a good way to go. How shall I pair? How shall I pair?
The sines and then...
Put these 2 together. Put these 2 together. So if I just rewrite this extra line, like so, put that guy there. Okay, I'm going to put the 2 there and the -10 there. You can see it almost now, can't you? Okay, let's take out the sine. That's going to give you 2 plus tan. I'll take out the -1. That will give you 2 plus tan. Okay, now I'm going to go all the way to the bitter end with this one. You'll see why. This gives me sine theta -1, 2 plus tan theta. Okay, 2 branches, right? Sine theta equals 1. tan theta equals
-2.
-2. Now, the domain of tan is all real values of y, so this is fine. This is going to get a solution. Reach for your calculator, and it should tell you something awkward like this.
Minus, yeah. And then you have the minus.
Or, oh, you just add 180. So this is it. Okay, now you got to be careful, because if you say into your calculator, if you punch in this, it will hand you a negative angle. It'll hand you minus 64, 63, something, but that's outside the domain. It's not from 0 to 360, right? So keeping in mind that tan is periodic every how many degrees? 180. So all you do is add 180. That'll give you an obtuse solution, and then you add another 180, and you'll get a reflex solution. Okay, so far so good. I've done that side. Tell me what's the solution to this?
90.
90 degrees. So how many solutions are there? Count them. 1, 2, 3. Wrong.
No, they're not inside the. No. What?
There are not 3 solutions, and I want you to stay. This is a really important point. It's really important. This was in last year's 2-unit HSC exam. It was one of the multiple choice. It's a great question. Why aren't there 3 solutions? Aha. This guy looks so innocuous, doesn't he? But he doesn't exist. Look, this is not the question. It's the tool that we use to get some solutions that might be the question. This is the question, and it's got tans in it, and tan exists here, and here, and here. It doesn't exist at 90 or 270. It's clever, isn't it? There are 2 solutions and 2 only. Thanks, everyone. Have a lovely week.